So let's go and talk about the curve, the plane curve. And when I say plane curve, I just mean in two-dimensional space. And if this is a curve of discussion, notice how, technically speaking, y is not going to be represented as a function in x. I certainly don't satisfy the vertical line test. However, if you and I can think of maybe arbitrary coordinates of points in this curve as being x and y, where maybe x and y themselves are functions in some other parameter, then maybe this could be an alternative way of looking at the graph of such a curve. Now, I'm being a little silly in the sense that you've already discussed parametric curves in your past. You just haven't gone into it very deeply. Now I'm going to dive into it at the calculus level, so we will get into it much more deeply. So take a peek, though, how if t is a parameter, then as t increases, I'm going to be tracing out this curve. And so from here on out, I'm going to have a habit of identifying the orientation of the curve, meaning as t increases, in which direction do I actually trace out the curve? So as a general rule, you and I are going to think of x and y as functions in t. So change my language a little bit. Maybe I can think of x as a function we call f in terms of t, and y as a function we call g in terms of t. My pen's running out, isn't it? So here's a simple example of a set of parametric equations describing a curve in two space, that is to say, describing a plane curve. Let's see if I can grab a better pen real quick. Aha, here you are. Now, I went ahead and just took the opportunity to add x and y for various different t's if I restrict t range from -1 to 4. And so if I plot these points like -2, 3, then -1, 2, etc., these ordered pairs in the xy coordinate plane that were generated by these corresponding values for t, substituting those two equations as t ranges from here to here. Now, I don't know, I'm going to be a little sloppy. -2, 3. Then maybe -1, 2. 0, 3. 1, 6. 2, 11. And 3, 18. I know I'm being a little sloppy, but the point is, tracing out the curve, it looks somewhat parabolic. I'll put my orientation in, clearly identify the endpoints here and here. And it actually does look like a piece of a parabola. Well, in reality, it's definitely parabolic as a relationship between x and y, because if I came in and what I refer to as removed the parameter, that is to say, tried to build a relationship involving only x and y that describes this curve, then I could do it by brute force, meaning if in the top equation I isolated my parameter, and then substitute this expression in terms of x in for t in my second equation, doesn't that second equation become this? Now, there's no need to clean that up. Technically speaking, that's already in at least one standard form where I can identify the location of the vertex as being a -1, 2, and it looks like that's exactly what's going on. Of course, I give a restriction that x lives between -2 and +3. Okay, so maybe these examples aren't sophisticated enough yet. We are certainly getting there.